I'm not sure if it's exactly time to start, but I'll go ahead and start. My name is Bill Venners, and today my goal is to compare functional air handling in Scalaz and Scalactic without creating an explosion on the Scalaz mailing list. So we'll see how I do. In particular, there's two types in Scalaz. One of them is called Disjunction, which is that V shape. It's a symbolic name. And then the other one is validation. For those who aren't familiar, disjunction is basically a biased either. So it's something that's geared towards functional error handling. If you're writing a method that may succeed or fail, you can return a left that has the success value and a right that has the success and a left that has the failure value. So you can actually return the failure instead of throwing an exception. That's the idea. And the difference between disjunction and validation is that disjunction is monadic, and it would short circuit. If you put it in a for expression, you can kind of combine many method calls that may succeed or fail, and it will short circuit and give you the first error. Validation is used for accumulating errors. So it's when you want to combine several method calls that may succeed or fail, but you want to know what all of the errors are. Okay? Or does the same thing, but in one type, right? So what I wanted to do was not be controversial, if possible, and start by kind of explaining what I think is a lot of the differences in the design. The way the design came out is differences in goal. So what us versus them is that I think the Scalaz folks are designing for us, and I'm designing for them. So when Tony Morris started the project, he said that he doesn't really care if it's used, he just wants it to be usable. And what I think that means is that he wants to use it. And so in particular, people who, he's designing it for himself, and people like him who are already familiar with FP. So that's who us is. Whereas I'm actually trying to design this for people who aren't familiar with FP. So that's more, I do want it to be sort of a way for people to get into doing things in a more functional style, people who are not familiar with Haskell or FP before. So that's one difference. Another is the people who, the powers that be or the powers that survived the recent ordeal really like type class coherence. And I don't think it makes sense. So the type class coherence goal is really something that informed the Scalaz design. And the fact that I'm not trying to do that has informed the Scalactic design. So that's another difference. The other thing that I find is that there's a real strong desire to make things general in the Scalaz community, which I think is a good thing. But I think that there are times when it's good to be specific. And that's another difference, I think, in like philosophy that made these two designs come out differently. One more is that the folks in Scalaz really want to do FP. I mean, this is my opinion or my impression. They're not really in love with the JVM because it's kind of it's not the best fit for FP. But it's so pervasive that you often end up writing things for the JVM, so it'd be nice to have something FP-like on top of it. And Scala is pretty much the best way to get there, and Scalaz is sort of the layer to do that. Whereas what I'm trying to do is more merge them together, like bring OO and FP together. I think a lot of the Scalaz feeling is that OO is not really needed. Regardless of that, what I'm trying to do is merge them, which I think is kind of what Scala is more about. So the last thing is that they don't like the standard library that much. There's parts about the standard library that they want to just not touch, so they make replacements. And what I'm trying to do is do something that will fit in with the standard library. So those are just, there's nothing wrong with the way they're doing it, I don't think. It's just different, right? So that is basically my intro. And I have just a bunch of demos, so I need someone to hold the mic for me. Otherwise, I would have to do coding with one hand. This is,
call me Mike Stand.
Yeah, this is Josh Shurit. So he's going to hold the mic for me and interject comments from time to time. That's fine. All right, so essentially, the thing about type class coherence, if you look, I've been in the Scalaz mailing list a few times, mostly asking questions, kind of as a curious grasshopper saying, why did you do things this way? And one of the things I just didn't understand is why do you have two different types? You have a disjunction type and a validation type. Because what I saw in the community was people would have confusion about which ones to use when. And the answer was because there's two different applicatives. So disjunction has a monad instance, and that comes with an applicative that short circuits. Validation needs a different applicative that accumulates errors. And they want to use applicative to accumulate errors. And because they only want one applicative per type, that makes them have two types. That's why they did it. So what type class coherence is that for any type T, there's only one instance. That's what it means. And you can always rely everywhere on that instance. So what happened in Scalactic is, first of all, I don't use applicative for accumulation. I just wrote an API for it, so I didn't have that problem anyway. But even if I did, I don't think, I mean, I see how type class coherence is an attempt to make things simple. You look at a type, you know what its instance does. But I think it doesn't really map reality. A lot of times there's just naturally more than one instance for a type. So let me give you a quick tour of OR. This is the, oh, sorry. Yeah, that was good. Yeah. This is the type OR. It's an either, so there's two possible values, a disjoint union. One of them's good and one of them's bad. So if you look at either, it's very balanced. This one is it's like an easier design just for functional error handling. So one of them's the success result and one of them's the failure result. I call them good and bad because success and failure were taken in the standard library. And to fit in the standard library, I didn't want to use the same name. But that's what it means. And so G is the good type and B is the bad type. Maybe it's an error message string. Maybe it's some kind of hierarchy that you created to handle errors. And then good and bad are just subtypes. Those are the two subtypes. So good just takes a G, if I can get there. And bad just takes a B. OK. So if one quick demo of how you would use it, if you had a if you had a method and you want to return either a string or if something went wrong in error message, you would actually put the result type of your method like this. You can just say string or error message. Or if you wanted to return an int, or if something goes wrong in error message, you could say int or error message. Well, learning. He learned. So this syntax here, I'm not sure you've seen it before. You can actually do that with any type in Scala where there's two type parameters. So another way to write this or int comma error message is int or error message. And you can do that with map. If you map from int to string, you could write that int map string if you wanted to. And then here's a method that's going to return a person or error message. And it calls those two guys in a for expression and just yields person. And it will short circuit at the first sign of failure. So if the first one fails, it'll just give you that error message. OK, so that's a quick tour. And one of the things that I wanted to do was test that this thing obeys the functor laws and the monad laws. And so this is an example of testing that this type obeys, its map method obeys the functor laws. And for that, I need to make a functor instance for OR. And so this guy, what it does is it calls the map method. And the thing is that there's also another method on OR called bad map that maps across the bad side. And that one should also pass the functor laws. So I wanted to test that too, right? And so that's down here. This says the bad behavior of OR should also pass the functor laws. So I have a different OR functor that calls bad map. So right there, there's actually two functors that are useful for one type OR. And that's the problem with I have with type class coherence is that it's kind of contrived to just force that into one, right? And the other thing that I demoed a year ago or two to the Scala Z folks is that there's a way in Scala to override an implicit. So you could actually have sort of a default type class instance, applicative instance for disjunction, and then if you want to accumulate, just put a different applicative in scope for that, and then accumulate with disjunction. So here's an example of I took disjunction, Scala Z's disjunction, and I was able to accumulate errors in it. I didn't need validation. Right, but what that violates is type class coherence, because now I've used a different applicative for disjunction. So, okay, so that's type class coherence. So actually, I'm going to take questions at the end for the video, but just save it. And also cries of blasphemy, those kinds of things. Please save those for the end.
Can I ask what happens?
Sure.
What happens if the bad map breaks? Do you get a Breaking Bad map?
Oh. So clearly, I hired the right guy. Yes, you do. I'm not going to tell you how it ends, but okay. So what I wanted to show was an example of what I've noticed in users. They will have a little bit of confusion about which one of these two types to use. So this person, actually, I don't know who it is. I'm sorry, but Olay Traveler. Sometimes the people don't really sign their blogs, but this is an article called or a blog post called "Favor Disjunction Over Validation," where someone says they had the epiphany that they've been using these two wrongly, and that most blogs show them to use them a certain way, which is his first demo here, which is simply if you have a bunch of methods like parse age, parse int, parse age, parse name, those kinds of methods where you're returning either a success value or a failure value, that you would return, if you want to accumulate the errors, you would return something like this. So this, oh, it's very tiny. Let me make that larger. Sorry. It won't go up now. There we go. Validation, non-empty list, error message, comma, int, which means if it succeeds, it'll return an int. If it fails, it'll return a non-empty list of error message, which he's type alias to string, this guy has done. And then down farther, what you can use is the Cinnabon operator or the Home Alone scream operator, whatever you want to call it, to accumulate errors. And so what you do is you take a few of these together, right? So this is like calling parse age. This is like calling parse name. And you take those together and you put, well, this whole thing is calling that. And then you pass it a function. It's very much like well, something I haven't shown you yet, never mind. So this is a function that will return, if all of those succeed, it returns a successful result of this function. Otherwise, it gives you a non-empty list of all the errors. Okay? And what he says that his epiphany was that the problem with it is that this type here is it doesn't really fit, because this is only ever going to return one error, either an int or one error message. But it doesn't say that. And he thinks that's problematic. And it also, there's a problem he mentions with requiring a semigroup in the wrong place. But what he suggests people do is use disjunction instead. So now he's rewritten his code, and this is how he does it now, which is you use disjunction everywhere. And you only, so what this means is if things go well, you're going to get an int back. Otherwise, you're going to get a string, which is what error message means. And then down here where you want to accumulate, you actually convert all those disjunctions to validations before you pass it to the Home Alone operator, right? And then you call that Home Alone operator thing, and then you convert it back to a disjunction, right? So I think that's kind of verbose. So he talks about how that's kind of verbose and how then he made a implicit to make that less verbose. So that's the kind of thing where I think it like having two types adds some complexity. I mean, type class coherence adds simplicity over here because when I look at validation, I know what its applicative does. But then it adds, the complexity pops up somewhere else. Okay, so the way that looks in Scalactic, where we don't have two types, is one thing I did was I added a every type, which is, there's a non-empty list in Scalactic called chain, but there's a non-empty vector called every, which is really designed for functional error accumulation. And an every is either a one or a many. So there's two subtypes of every. A one is like a sum, and so it just takes one thing. So here's a one that takes the lone element. And a many takes at least two, right? So here's a first element, second element, and maybe more. Right? So an every is either a one or a many. And what that allows you to do is if you really want to write some method just for, that will be immediately accumulatable, you can say it's a string or one error message. So you can't actually say in the type that this is an accumulatable error, but there's only one of them, right? And now here the parse H is enter one error message, and then the parse person method now returns a person or every error message, because it may be one or two in this case, right? But it's always every error message that happened. And then instead of using a for expression, you use this thing called with good, which is kind of like the Cinnabon operator, but not as general, right? It's just a API that only takes ors that's just for accumulating errors. So the difference there, I think, that's one of the differences where they like generality and they want to use the same algorithm over and over again, which I think is good, but if you're not familiar with FP, to figure out what that little @ part does is you have to find it in Scalaz code. There's no documentation. And then if you figure out it's doing something with applicative, you got to look that up. There's a good paper on that, but that uses Haskell, so maybe you should learn a little Haskell. And then it's just, if you don't know FP, that's a big hurdle. So for the people I'm actually targeting, I'd rather have them just call the with good, follow the with good method, and they can look at the documentation and kind of figure out what to use. So it's easier to Google, and I think the downside is I had to do more work. I'd have to write more code. But I think that if it makes things simpler, that's a way I can provide value. So both, there's trade-offs, right? It's good to actually minimize code duplication, but sometimes, for example, performance, you may re-implement an algorithm, or in this case, I think it's just simpler for the people I'm trying to reach. Okay, so that's usability. So let me close these guys and go to the next one. No comment? You can make a comment.
I've had a tongue. I'm just
Okay.
holding.
Oh my goodness. Okay, you're holding at the end. All right. All righty. So essentially, I wanted to show. The thing I just talked about was kind of the trade-offs of general versus specific. With good is a specific API for accumulating errors, whereas the one that Scalaz uses is general. So you can use it for other things. But here's another case where I think they tried to make things general by using a monoid in the filter method. So this is the filter method on validation. And it takes a predicate from the good type to Boolean that says, is it still cool? And a monoid that they use the 0 value if it is not cool. And so if you get a failure back if it's not a valid in some, whatever that function is testing. So disjunction is the same way. They also take a monoid and they use it for this means bad because it's a left, because that little arrow is pointing to the left, that means left. Left is the failure side. So what I wanted to show was an actual demo in the REPL of what happens when you do that. So I've imported Scalaz here, and I just made an age method, age field value that is of type validation string come int. So if it was successful, it's an int, and if it's a failure, it's a string. And I've made 42. 42 is a valid int, right? So it's a success. So if I do this filter, which may show up in a for expression, I'm going to say I'm going to filter out anything that's not a round number, right, divisible by 10. And what I get back is, since this is not, I get back the monoid 0 for string, which is an empty string, right? So my failure message is an empty string. And the good thing about that is, like empty string failure messages, is when you print out the log file, you save a lot of paper. But it can be frustrating, right? And I don't quite understand why and I just sort of feel like this is too general and doesn't really fit here. So what you get when you do the same kind of thing in Scalactic, let me find my code here, is, let me demo it. Let's also put Scalactic in there. Basically, when you do the same thing, you get a compiler error on purpose because I don't know what you want for your error message. And so what I did differently, which I wasn't sure was kosher, actually I talked to this guy about it one time, and he was non-committal. But what I did was I said, if I can find it here, okay, the filter method on OR doesn't take something that results in Boolean. It takes something that results in this thing called validation, which is, this is Scalactic's validation. and it's different. What it is a option with attitude. So this guy's either a pass or a fail, and a pass is kind of like none. It's just an object. It means it was cool. And this is kind of like the type of a test. Like when you run a test, you don't really want a value back. You just want to know if it passed or not. But if it failed, you want to know why, right? So fail actually has an error type in it. So that's what I thought made sense for filter, because if this thing fails, I need to know what error type to return. And so what you'd have to do once you get this compiler error is replace it with something like this. Whoops, not like that. Not very good with computers. Okay. So instead of passing a Boolean expression, I have to pass an expression that actually returns a validation of, in this case, error message. And so now what I get is 42 was not a round number, right? So I think that's I don't understand it at least. There may be something I'm not getting, but that seems like a pretty major usability issue in their approach and it's like sticking monoids where it doesn't really make sense. Okay, so FP plus OOP, I want to actually go to, back to the slide. Okay, hey, I'll take this off your hands for a sec, but then I'll need you in a sec. But thank you very much. And yes. So one of the things that I've had discussions with Tony Morris about is identifier naming. He thinks I'm too focused on identifier names, that I make more out of them than I should. Whereas I think I'm probably too focused on it, but I think he's not focused enough. And what he talks about, which does make sense, is that you want to actually look at the types, not the names. I do agree with that. And, but he kind of talks about identifier naming as if it's a dynamic language. And what I wanted to say was that, in Java, the Java way is that you're really not reasoning about identifier names. What you're reasoning about is the contracts of the types. And the names just remind you what those contracts are. So what I've drawn here is basically how I got into all this stuff was I wanted to, when I created OR, I didn't have a way in Scala to say OR should pass the monad laws. And so I've been trying to come up with a nice syntax for laws testing for Scala tests. And it means I need a functor type class and a monad type class and a applicative type class and whatnot. And so this is what it looks like right now in our master in GitHub. And what basically a monad in this case is an object. And an object has an interface and an implementation. An interface, it consists of these signatures that can be checked by the compiler and a contract that is got to be looked at or checked by tests. And that's always been the case. What's different about monad and functor and applicative is that the interface is just, the contract is just expressed in terms of algebra, like mathematical equations, which is a good thing because it's clear, right? It's also general. So, so anyway, that's one of the things I wanted to say is that, one of the things I've heard from folks coming from FP is that they don't really have a lot of need for OO, that FP is composable and actually realizes the promise that OO gave but never did, right? And what I wanted to point out is that it is composable, FP, but that there's nothing unobject-oriented about this, that what makes it object-oriented programming composable is bringing FP to it. And that's what Scala is about. So, so anyway, that's what I wanted to say about that. And I think I think Scala is an object-oriented reform movement. Object-oriented programming was historically founded in objects have state and encapsulate state. And what Scala says is, well, you can make them immutable and actually get the benefits of functional programming. So OO does need FP. And FP probably doesn't need OO, I would say, but what Martin always points out is that if you're going to make a pure FP language, functional programming language, you need to have some way, if it's going to scale up, you need to have some way to put your functions into modules so that there isn't one global namespace, and objects provide a way to do that. So that's sort of what OO is one thing it can bring to FP. Okay. So what, I did want to say last, yeah, go ahead. I did want to say last was this, what are these things good for if you're really like applying them to OO, like monad and applicative and functor? I mean, one thing they're good for is testing, because I think it's very useful to say this should pass these laws and that you get a nice test. And it's very useful to say these are, express your contracts, your object-oriented contracts in terms of algebra. So that's where I'm starting. And there's other uses, certainly, but I haven't really got there yet. Okay, so the last thing I wanted to do is look at the standard library stuff. And can somebody tell me how much time I have left? Just there it is.
24 minutes.
That's how much I've left? Awesome. So one of the things that I mentioned early on was that I wanted to make things fit the standard library, and I do that just because I think it's simpler for users. So one of the differences is that I had the audacity to put the good value on the left and the bad value on the right, which was like everybody thought that was strange. And the reason I did that is because it fit better I felt it fit better the standard library. That first transform method is try, and that takes two functions. The first function it takes is the success one, the success side, and the second function it takes is the failure side. The next transform method is from future, and its first function it takes is for the success if it succeeds, and the second one it takes is for the failure. And the third one is or. The first function it takes is success, so it's on the left, and the second one it takes is the failure, it's on the right. The other one is called bimap from Scalaz, and it does the opposite. It takes the error first and then the success second, and so OR is consistent with the standard library. Disjunction and validation are consistent with Haskell, and there's nothing wrong with that. Haskell has a very good reason to do it that way, and it's because they partially apply types one at a time. They're all curried. So there's a really good reason to do that in Haskell, and there's no problem with doing that in Scala if that's what you want to do. But Scala actually doesn't curry types, so there's no advantage of putting it on one side or the other. So what I did is I thought it actually read better to say, put the happy path first, int, or if something goes wrong, error message. And I thought that it fit better with other examples in the standard library. Okay, so that's that. And another example of what they did was, these are the old ones. Let me get rid of these guys. ilist, save seeks, and okay. They have a couple things that are like replacements for things in the standard library. Like they have one called maybe, where which is a replacement for option that doesn't have, with a big fan in the middle there, it doesn't have a get method. So you can't shoot yourself in the foot that way. And it was, I think, really worth putting in because of the message when the person submit the PR was, this is crazy, but option has get, so call me maybe. So I think that was pretty funny. There's also an ilist, which means invariant list. And the point of that is to get a type safe contains, because Scala's list and all of its seeks, most of its seeks are covariant. And if you try to say that contains just takes type A, it won't compile because it'll say that there's a covariant position, a covariant type parameter and a contravariant position. And the reason that's there is because someone could write a contains method if you'd allowed that, if the compiler allowed that, you could write a contains method that blows up at runtime, right? So it's not sound. Most of these contains methods aren't written that way, but it could happen, right? So what I tried to do was, Paul Phillips is probably here somewhere. He also had, Paul Phillips had also posted one of these on a gist at one point, and I showed an example where you could implicitly convert away the covariance and actually get a type safe contains. And he and Lars at that time was still in the Scalaz world, and they both informed me that I was relying on an implementation detail of type transference. And I went back and forth with Paul a little while, and he said it probably won't change because there's bugs that actually rely on it being fixed, he said, but it's probably won't change. But I didn't quite like that. But I also wanted, I trust Paul, but I wanted to verify. So I tried to find a way to prove him wrong. And so what I came up with was I actually came up with a way you could do this without an implicit conversion, with an implicit parameter. And so this type safe contains method on every was actually, every is covariant, and it's actually on the type. It's not an implicit conversion. And then I added a safe, there was an implicit conversion that would add safe contains to list and using the same technique. But I looked at that, and there was a minus sign in the type, and it was just left in there, just because I'd copied it from another type class. And I thought, well, actually, if there's a minus sign there, that means I could put any there, I think. So I tried to take the minus sign out, and I got a compiler error, the usual contravariant position. So it's like, uh-oh. So I actually typed in the type class explicitly with any, and it compiled. And so then I knew I was still relying on an implementation detail of type inference. And so I don't have a mathematical proof that Paul was right, but I have a gut feeling that there's no way to do it. So then, and the other thing is, it's like, who wants to write safe contains? What people want to write is contains. So I got to thinking that it really needs to be, either you need an invariant list, or you need static analysis, something that's outside the type system. And then I thought at first that maybe we should put that in the compiler. That was my first suggestion. But having done all the equality stuff, that I kind of was aware of it's a lot of complexities. It's not as simple as you would hope. So then I decided to write one. So that's what I actually released this morning at 2 in the morning. It's called SuperSafe. It's a plugin. And if you say list 1, 2, 3, this is Scala's list dot contains 1, you get a type error. So I think that's what, if I were designing a language and a library from Greenfield design, I would try to make that a type error. Sorry, I said type error. It's not a type error. It's just a compiler error. I would try to make that a type error. But since this is the list that we have, then I think this is a good way to do it. The other thing this guy does is, for example, it'll say catch things like comparing an option of string with string for equality. So these are things that I think are, at some point you need to use static analysis to find problems. Okay. So, all right. The second last thing I want to actually do, I'm going to have to grab something out of my bag. I forgot to get ready. Is these guys, Andrew and Nerman, wrote a puzzlers book, and it's a really awesome book. It just came out a month ago. Scala Puzzlers looks like this. So we're going to give away 6 free copies of people who can actually put together these little cubes, and I'm going to toss them out in the audience like little flippy cards. And what we're going to do is we're going to sit near the coffee stand at lunch and at this afternoon break, and anybody who wants to buy it, it's half off. It's $20, cash only. And whoa! Oh, I'm going to try to get some away in the back. Ooh, this is fun. I'm going to go to that side. Oh yeah, sorry. This is fun. All right, see if I can hit the back row. Oh no, sorry. If I hit him in the face, I'll try not to hit him in the face. All right, way there in the corner. Oh, sorry. Okay. Okay, so that's that. Okay. And then the last thing I just want to leave you with is kind of this idea of gardening where you are. I live in California, and where I live, it doesn't rain for 8 months out of the year, even when in a normal year. And I had a lawn, and I pulled it up because lawns take a lot of water, and I planted native plants that are adapted to drought, right? So they don't take as much water, and we like it a lot better. All my neighbors have lawns, and they're really nice. I like them, but I'm doing something different, which is I'm trying to make something fit. So I'm not saying that OO is better than FP or any of that kind of stuff. I'm just saying where we are is on an object-oriented platform. I mean, the JVM is at heart an object-oriented platform in an object-oriented industry. And so the way to sort of make that better is to bring FP in and merge it with OO in a way that makes sense to those folks. So that's what I'm trying to do. So that's all I have.
15 minutes.
And I have 15 minutes for questions. Thank you. Thank you, Josh. Yes.
We really like this library, so thank you very much for it.
You're welcome.
What or,
Yeah, future of an OR.
especially in the order we're just
Yeah, I think the question is about, is it a future of OR, or a future of OR of OR of OR, or which? Okay. I don't know, but can you come up afterwards and I want to understand the use case. But one of the things that I think, like another thing that the Scalaz folks didn't like was try. And I think try is useful for, you need it because anything can blow up with an exception. So you need a type, a disjoint union where the bad type is an exception, because a throwable, because it just could happen. If you're going to do something async, you really need that to come back. So if you also are calling something that has an OR inside of it, where do you put it? You really have 3 states now. And so one of the things I thought, which was to make an extractor so that instead of saying success good, success bad, which sounds like it's like a successful bad is weird, you could have the good, the bad, and then the ugly would be the exception. But I think that's too cute. But there's something needed, I think, for handling 3 states, and I don't know exactly what it is yet. So yeah, come up after and we can talk about it. Yes, Daniel.
So,
I don't. Maybe it is. I'll have to look. It might be. But I'll tell you what it would be. I know an answer to that. I just thought of, which is it would work in a for expression. In other words, if you make a filter in a for expression, then it actually works, as long as your filter, your if has something that takes a validation. It just rewrites it. It doesn't care if it's a predicate or not. So I was trying. I mean, that's another way to try to make it fit, was like make it work in for expressions and that kind of thing. But I had actually when I was doing we were doing the applicative stuff, I had one of my with goods. I didn't realize it until we were doing the applicative stuff, but it's the same as map, so I should really deprecate. There's a with good with one thing. It's actually map, so I need to deprecate that one to remove it. So anybody else? Yes.
Your OR type needs to know, or the bad subclass needs to know about the good type. Can you comment on that?
That's a good. Okay, that's a great comment. So that was one thing I wasn't sure about either. I'm sorry. Can you? Yes. What he said was that the good type, like here's OR, and if I go to good, it's true for bad also. Okay, so OR takes a G or a B.
Great Britain.
Yeah, good boy. B, where's the good one? So the good one just takes a G, but it has both types, right? And it's like either. Either does that too. The other way I could have done that is just say, takes one type and extend OR with nothing. Because they're covariant, that would have worked. And actually, the type system was, I think, telling me that because I had to do a cast. And if you look in the code, there's one place where I cast.
This is for questions.
Oh, thanks. There's one place where I had to cast. So I think the type system was telling me I should have done that. But I wasn't sure because you lose the type. If you ever go down and want to go back up, you've lost it. So what I did is I did what either did. But that may be, I'm not sure that's the right way to do it. But that's what I did. I did make some syntax to make it easy to deal with. I tried to. But I'd be interested if people have comments on that afterwards too. Ideas about why it should be one way or the other. Anybody else? Yes, way back in that guy.
Hi.
Hi.
Okay, you said, correct me if I say this incorrectly, you said that Scala is a reform movement for OOP, is that right?
That's my opinion. I said that, yeah.
Yeah, so I
Yeah.
think people would tend to agree with that. And then you went on to say that if you remove mutability from Scala, that's effectively making it not OOP. I wanted to ask you.
Oh, no, I actually didn't mean to apply that, no. I think functional OO is still OO, and it doesn't need immutable state. What I said was that if you remove OO entirely from FP, you have FP, and FP doesn't really, Scala is not an FP reform movement. What needed help was OO by bringing a functional in. That's what I meant.
That's what I'm confused about is, I mean, you have things like modules in Haskell, ways to prove functions under things. Would you then consider Haskell to be OO?
No, I don't. So not all module systems are object-oriented. So what OO provides to FP in Scala is that's the module system. So that there's one system. What Martin likes to say is there's one system in the small that also can be used in the large. So it can be used for the module system. But FP languages can have a different module system that isn't object-oriented. It just, in Scala, it happens to be that. Does that answer your question?
Sort of. I'll just come and talk to you afterwards. I'm curious
Okay.
like, what the OO penis is in the, OO module system, but I'll talk to you afterwards.
Okay. All right, anybody else?
I just had a question on the symbol
Sure.
versus names. It's like if they did this for disjoint,
Yeah.
why pick a symbol or just do multiple? I'm just confused. Sometimes they'll pick a symbol, sometimes they don't.
Oh, I don't know. I think this one looks like, if you look in the mathematics, that looks a lot like the mathematical meaning. So this one I think is nice. I don't like that one I find, because I don't think I'm dyslexic, but when you see a bunch of those, they kind of move, and I have to really think. Okay, that one's pointing to left. Okay, that's a left. I have to do too many mental hops. But yeah, I mean that itself I think was not bad.
So I actually think the disjoint union symbol was, they designed that after they watched the Mighty Ducks.
Alexi, yeah.
I will throw a question. So what is the future of Scalactic? Do you want to implement the
No.
Scalaz
No.
functionality in it?
No, the question is, what is the future of Scalactic? So I've been trying not to, but what's interesting is that a lot of all the stuff in Scalactic came out of testing and things that from Scala's people asked for that they also wanted in their production code. So there's an equality there that people wanted to do a custom equality for their testing, but they also needed in their production code. And very specific problems they were having that just wasting their time having to catch those things at runtime. And that overlaps with equal. There was something else. Oh, OR. So OR came from someone asked for, like, Scala tests, they short circuit. Because usually you want to, when you find a bug, you actually want to quit and bail out. Otherwise, you get a bunch of failures that don't make sense or don't add any information. And it may take longer. But sometimes people wanted all the errors. They wanted to accumulate all the assertion failures in a test. So I made a type for that, which was imperative, which I thought fit. Once you kind of go down the exception throwing, things stay kind of imperative. But I wanted to see how do you do that functionally. And that's when I first came to Scalaz and was looking at their stuff and asking them why they do it this way and that way. And so they kind of came from testing also. And pass, fail is very much the type of a test in your production code. So monad and applicative and functor comes from, when I wrote OR, I wanted to actually test that aspect of it. And I thought that was important. I really did think that the Scalaz folks were right about that way of testing. So I thought it should be in Scala test as some kind of syntax, and I just needed type classes. But there are no instances. It's just for testing currently. So that's where I'm starting. And actually, there's a bunch of these type classes popping up in various places, and they're not all focused on the same thing. This one's focused on testing. So, yes, 4 minutes, 5 minutes.
Comment on either in the standard library.
Yeah, that was another difference I sort of had with Tony. I think he didn't like either, even though he wrote it. He felt he was, people guided him in a bad direction. And what I feel is that it is not good for functional error handling. I agree with him on that. But that it is good for when you're not doing error handling and you need a disjoint union. That actually happens sometimes. You have two things that are equally valid. Like you need to pass in a file handle somehow, and you either have a string, file name, or actual Java IO file. Doesn't matter which one you pass. It's not like one is good and one is bad, right? That's what either is good for, so to speak. And so I use it for that. So I use or and either together, whereas what I think those guys, well, I don't know that. I'm not sure, but I get the impression I got was that either was bad and you should use disjunction. Actually, he said that in a tweet. So I think that's what he thinks, but I like either.
I have a question.
Yes.
So, given that this uses OR as a type operator, would
Yes.
you recommend type operators to other API developers?
You mean like the thing, putting it in the middle?
Yeah.
I guess so, if it makes sense. It just, I'm not sure how often it would make sense.
Have you run into any like weirdness with syntax, I guess is what I'm asking.
Okay, the only thing that I would be nice is that when you make an OR in the REPL and it shows the type or a compiler error, it doesn't infix it. So it might be nice to be able to annotate a type saying, please show this in infix. I think that's already been requested. So the same thing with disjunction. It shows it the old-fashioned way with square brackets and all that. It'd be nice if that just always showed up infix. But otherwise, no, that it really works the same. So, okay, all right. I think that's it. Thank you very much for coming. Thanks. Hopefully I didn't start a war. Oh yeah, thank you.